Number 30 says the area of the region in the first quadrant between the graph of y equals x times the square root of 4 minus x squared and the x-axis is, and then we have our 5 answer choices. To find the area bounded by this curve and the x-axis, we need to find the integral of that function between a and b, where a and b are the points where the curve intersects with the x-axis. So to find the two x-intercepts, we need to find where does this equation equal 0. We can use the zero product property, since this function is already in factored form, to set each factor equal to 0 and solve them individually. X equals 0 is already solved, so we've got that x-intercept. But to get the other one, we need to square both sides of this equation, then subtract 4 from both sides of the equation, divide both sides by -1, and then finally take the square root, and we get x equals plus or minus 2. So this function is a total of 3 x-intercepts, but we only care about the ones that are in the first quadrant, so we're really only going to concern ourselves with x equals 0 and x equals 2. We don't know exactly what this function looks like, and you're not really expected to know what it looks like, so I'm just going to draw some sort of weird curve. We don't know what that curve looks like, but we're just trying to find the area underneath it. So now that we know the boundaries, we can change that a to b to be from 0 to 2. So we're looking for the integral from 0 to 2 of x times 4 minus x squared dx. This integral is going to be solved using u substitution. So that means that we are going to substitute an expression in this equation with something where we can find a modified version of the derivative also in the expression. So we're going to use u substitution and select u to be 4 minus x squared. Now we don't have the derivative of that directly in the equation. Du would be negative 2x dx, but in our expression we only have x dx, so we need to rearrange this du equation by dividing both sides by -2, and we get -1/2 du equals x dx, which we actually do have in that expression. So now let's go ahead and make our u substitution, replacing 4 minus x squared with u, and replacing x dx with -1/2 du. So this is going to be the integral from not 0 to 2 anymore. We can find the new boundaries under this u substitution by plugging in 0 and 2 into our u equation. So 4 minus 0 squared would be 4, and 4 minus 2 squared would be 0. So we have this new integral from 4 to 0 of -1/2 square root of u du. Next, I'm going to factor out the -1/2 here and also switch the boundaries here. Notice 4 is actually greater than 0. So to make this a little simpler, I'm going to swap those out so that it's going from 0 to 4 instead of from 4 to 0. To do that, I need to negate the entire integral. So I'm going to actually do these two steps at once. I'm going to swap those two boundaries and negate the integral and also factor out a -1/2. So I'll have -1/2. The negative will just cancel out and become positive. So I have 1/2, and then the integral from 0 to 4 of the square root of u, which can also be written as u to the 1/2 power. Next, to integrate this, we need to find the antiderivative of u to the 1/2 power, and we can just use the anti-power rule to find that. So here I've got 1/2 times the antiderivative of u to the 1/2 would be u to the 3/2, add 1 to the exponent, and then divide by that new exponent. Dividing by 3/2 would be equivalent to multiplying by 2/3, and then we have a plus c. And we want to evaluate that from 0 to 4 using the fundamental theorem of calculus to come up with our answer. Now, one nice thing about the u substitution method is that you don't necessarily need to go back and replace everything that's in terms of u with expressions in terms of x. We can simply find the value with the new u expression. So I'm going to take this work, kind of push it over to the side here, And now I'll substitute in 4 and 0 into u and then subtract those two expressions. So here we go. We've got equals 1/2 times 2/3 times 4 to the 3/2 plus c minus 1/2 times 2/3 times 0 to the 3/2 plus c. Now, the plus c's we can more or less ignore because they will cancel each other out. Half of a c minus another half of a c, that sum will be 0, so we can ignore the plus c's. We can also, see that this second term, 0 to any power, is just going to be 0. So this whole thing's going to be 0. Multiplying by 1/2 is also going to be 0. So this whole expression over here to the right is just 0. So let's focus in on what we've got going on to the left. We have 1/2 times 2/3 times 4 to the 3/2 power, which is the square root of 4 to the third power. So 1/2 times 2/3 times the square root of 4 is 2, 2 cubed is 8, and now we're ready to multiply all those together. We have 1 times 2 times 8, which is 16, 2 times 3, which is 6. This can be reduced. If we divide both the numerator and the denominator by 2, we get 8/3, which is our answer. That is the area under the curve bounded by x times square root of 4 minus x squared and the x-axis. Our answer is B.